Welcome to the third podcast on this channel. In last week's podcast, we talked about the new Samsung Z Flip, SpaceX abort tests, and budget action cameras. Today we will dive into the past of car safety and how it might be an issue for the Tesla Cybertruck, and what SpaceX is doing with reusability in the space industry. So in the last two podcasts, I have been recording the audio on my phone laying on my bed. I realized this caused some background and volume inconsistency, so I have changed my setup. It is far from professional, but I've tried to make it sound a little bit better. The microphone has now been suspended, and I am on like a desk instead of a bed. I think it'll sound a lot better than my previous episodes. Just a heads up, this episode might be a little bit shorter than my other episodes because I didn't add 3 topics. As you noticed, there's probably only 2 topics this week. So over the weekend, I had some friends over and we built a parachute for the Alpha 2 rocket. The Alpha 2 is the first rocket going into the building phase. Alpha 1 was considered for a while to be my first rocket, but later thought showed problems and uncertainties with the design. Alpha 2 will just be a few feet tall and powered by a little charger engine. The little charger engine is a homemade 5-inch sugar rocket engine. It is made of PVC pipe and it should have a burn time of about 5 seconds. It has only 2 3/4 inches of actual fuel though. The rest is the ejection charge and nozzle. The Alpha 2 is predicted to reach a height of 1,000 feet and a possible flight time of 5 minutes. Most of that time will be in descent from the homemade plastic tablecloth, aka parachute, and that's what we made over the weekend. Anyway, changing gears, let's talk about the Tesla Cybertruck. Get it? Because Tesla doesn't have any gears? Okay, that wasn't that good. But hey, one of the most fascinating moments for me in the Indianapolis 500 was Scott Dixon's crash in 2017. It was a horrible crash and his car went airborne before crashing into a wall and spinning out and all sorts of bad stuff. Thankfully, he was fine, but it caused a red flag and the race had to come to a standstill until they could clean up all the mess. What I found most interesting was how the Indy car was destroyed and gone, except for the driver's seat area. This really is a tribute to the engineers to design and build incredible machines like the Indy car. The Indy car seems to be using what is called a crumple zone. A crumple zone is an area that, when impacted with a high force, crumples or deforms in order to spread out the impact. This action is similar to an airbag, which makes the impact with the car longer and therefore helps your skull not shatter, which you don't want your skull shattering. When Dixon's car impacted the wall, it was going close to 200 miles per hour. The car crumpled, saving Dixon's life. The engineers should be proud of how far IndyCar has come in safety in recent years. Regular cars do this too. Cars crumple in the front and you usually slow the impact. Normal cars are fairly dentable, and this the cause of a useful crumple zone. When Tesla unveiled their new Tesla Cybertruck, it was instantly controversial for its looks. Over the past few months, it has grown on me, but my bigger issue of it is safety. Tesla made a huge deal of the Cybertruck's new strong panels. They showed it off versus a normal door by repeatedly smashing it with a sledgehammer. This could be great for truck owners, but begs the question, will these new undentable panels be able to crumple in order to keep the people inside safe? The Tesla truck has shown in the presentation was just a prototype, not the final product. Tons of things may change before the truck is available for purchase in late 2021. There are multiple viable solutions to this problem, but might be a roadblock for future engineers and designers. A possible solution is to replace the front panels with less rigid panels with the capability to dent and crumple more easily. This is an easy solution and wouldn't probably be the best. It'd be kind of a last resort. Another solution is to specifically design a panel capable of not denting but also able to crumple normally. If they can make a panel stronger one way and weaker another, this could be the best option for truck owners because it would keep the passengers inside safe and keep the dentless quality. Tesla has been known for good safety ratings in the past, so I assume they have a plan to create a good truck that is also safe and strong. So last week we discussed the SpaceX abort test, and I mentioned how we could talk about reusability. The idea of rocket reusability isn't new. In fact, there were plans for the first stage of the Saturn V to be caught by a giant helicopter. Although those plans were obviously scrapped, the rocket reusability has been a goal since the modern rocket itself. The most famous and most classic of all reusable rockets was NASA's Space Shuttle. It was a huge advancement in the space industry, but was much less than what it promised by the Space Shuttle. The shuttle, when released, promised to be an unprecedented launch schedule, a crazy low flight cost, and the shuttle being the very first reusable rocket. None of these happened, though. Mainly, the shuttle failed because of the amount of refurbishment needed before each flight. The original plan was for the shuttle to get quickly checked and continue to another launch, much like an airliner. This check process was supposed to take about 2 weeks. In reality, it took 3 months. The reasons for this varied and were deemed necessary. SpaceX has tried to approach with their orbital rockets. Instead of flying like a plane, the Falcon 9 booster lands vertically using 2 thrust vector controls to have a slow, controlled descent. One thing people don't realize is that the re-entry process is extremely harsh. The plasma and air resistance heat of the shell of the rocket heats it to half the temperature of the sun. During re-entry is one of the hardest parts for the Falcon 9 rocket because it must have pinpoint accuracy, survive searing temperatures, and be able to function properly the entire flight, and, if that all goes well, be able to land with little fuel it has left. These rockets are several stories high, and they need to be able to nimbly come down for a soft touchdown. It is quite impressive when they do. The goal of reusability in rockets is to lower the average cost of space travel. In the past, highly priced technology was ditched after it was out of fuel and was either destroyed on impact with the ocean or during the re-entry process. Landing rockets is a way to only burn fuel and reuse the rocket frame and technology. One thing that's hard to do is make a rocket not refurbishable, but reusable. The difference is quite substantial. A refurbishable rocket must have many parts replaced after each flight and modifications made to keep the craft running. This is unlike a reusable rocket in which it is almost ready for its next launch upon landing. It just has to refuel and have a quick systems check before it is cleared to launch again. Well, I hope that helped. That's a little quick explanation of reusable rockets for you. I will not be posting for another month because I will be off of YouTube for Lent. So I will see you after Easter, and I hope this podcast will be fun and a good time to listen to. Remember to like and subscribe, and I'll see you after Easter.